You are listening to The Vocal Technologist. Spoken tech for your ears.
Imagine a world where a literal robot is paying for an article online using a currency created by cypherpunks.
Right.
But then, at the exact same moment, the United States government is building a quantum computer that could just crack open Satoshi Nakamoto's secret 1 million Bitcoin vault.
It genuinely sounds like a sci-fi movie pitch.
It really does. But, that is simply what happened in tech this July. So, welcome to today's deep dive. We have this fascinating stack of newsletters and research from early July 2026, and our mission for you today is to unpack this landscape that is, well, it's simultaneously growing up and getting incredibly weird.
Yeah, weird is definitely the word for it.
Right. We are going to explore how crypto is being tamed by global regulators, how Wall Street is colliding with on-chain realities, how these networks are secretly fueling a brand new economy of AI and robots, and, yeah, that looming existential quantum threat. We're going to break down the mechanics behind all of it, so let's just get right into it.
Let's do it. It's a massive dichotomy, really, because if we want to understand an industry maturing, we have to start with the foundation, which is the rules of the game.
Right, the regulation.
Exactly. We are seeing a complete divergence in how different parts of the world are handling digital assets, starting with a massive regulatory shock in Europe.
Okay, let's start there. Because as of July 1st, the transitional period for the European Union's MiCA regulatory regime closed. Like, no more extensions, no more grace periods.
Yeah, the door's shut.
All 27 member states are now operating under a single crypto authorization umbrella. And, the fallout was brutal. Out of over 1,200 previously registered EU crypto businesses, roughly 80% failed to transition.
Wow.
Yeah, only about 200 authorized firms remain standing today.
The sheer velocity of that contraction is just stunning. We are watching an industry that historically thrived in gray areas being forced into the harsh light of strict compliance.
Yeah, no more hiding.
Right. And for centralized exchanges, only about 14 are holding licenses now.
Yeah.
You have Binance securing approval in France, Kraken and Coinbase in Ireland, OKX in Malta. But the real story of this regulatory filter is who got caught in it, specifically in the stablecoin market.
Right. The massive loser here is Tether, the issuer of the USDT stablecoin.
Right.
They just never sought the e-money token authorization under MiCA.
Yeah.
As a result, major exchanges are effectively delisting them for European users.
Which is a huge shift.
Yeah, tell me about the mechanics of this. Why did Tether get pushed out?
Well, it really comes down to what MiCA considers an e-money token. Europe basically set a standard that requires stablecoin issuers to hold highly regulated, transparent reserves in European institutions.
Okay.
And, they have to comply with strict prudential requirements. Tether, which operates with a much more, what's called an opaque treasury structure, they chose not to jump through those specific institutional hoops.
So Europe just drew a hard line.
Exactly. They set a clear, albeit very difficult standard.
Yeah.
But if we cross the Atlantic to the United States, the strategy from the industry is entirely different.
Entirely different, because the U.S. still lacks that clear rule book.
Right.
So the strategy in America isn't to comply with the rules, it's to fund the people who write the rules.
Yeah, exactly.
Looking at the sources, crypto companies have dropped $189 million on the 2026 U.S. election cycle through June 30th alone.
It's a staggering number.
For context for you listening, that is 37% of all corporate political contributions. The Fairshake PAC, which is backed by Coinbase and Ripple, spent $82 million. The Meiji Inc., super PAC backed by Crypto.com, spent $56 million.
And we really need to look closely at how this money is deployed, because the data from Public Citizen shows a very specific strategy here.
Oh, how so?
Well, these PACs are operating across both Democratic and Republican contests completely impartially. Yeah, they are strictly prioritizing the business interests of their backers over any sort of party alignment. They're playing both sides of the aisle purely to secure a favorable regulatory environment.
Which brings up a critical question for me. Does this sheer volume of political spending actually buy regulatory clarity, or does it just create more friction?
That's the million-dollar question, or I guess the $189 million question.
Exactly, because capital doesn't always equal votes. Like, look at New York's 12th congressional district. A heavily funded, crypto-backed candidate there just lost the primary to Michael Lasher, and Lasher actively campaigned against the involvement of crypto founders in that very race.
Right. That race totally proved that high-stakes brute force lobbying has its limits.
Yeah.
It highlights the impossible choice these companies face today. Like, it's kind of like Micah is a strict bouncer checking IDs at the door of the club and turning Tether away, while in the U.S., the industry is just trying to buy the club outright.
I love that analogy.
Right. So they either accept the strict, expensive compliance of Europe's MiCA, or they roll the dice on these incredibly expensive political battles in the U.S., just hoping it translates into friendly legislation down the line.
And while politicians argue over the rules, traditional finance is absolutely not waiting around. Wall Street is diving into these assets.
At first.
But looking through our sources, the results are this chaotic mix of spectacular failures and quiet triumphs.
It's very polarizing right now.
Let's look at the old way Wall Street operates, speculative leverage, starting with MicroStrategy. Their enterprise MNAV, which is net asset value, just dipped below 1.0.
Okay, this requires a bit of unpacking for sure, because MNAV is a crucial metric. When we say the MNAV dipped below 1.0, it basically means the public market is now valuing MicroStrategy's entire capital structure.
Like their debt and common stock.
Exactly, their debt, common stock, cash. The market is valuing all of that at less than the actual face value of the Bitcoin sitting on their corporate balance sheet.
Hold on, let me make sure I have this straight. Their Bitcoin stash is worth roughly $51.1 billion, but their common stock has plummeted to around $82, which is 85% off its November 2024 peak.
Right.
And then there are these STRC perpetual preferred shares, which carry an 11.5% yield. They are trading around $75, which is a 25% discount to their $100 par value.
Yeah, it's getting messy.
So walk us through the mechanics of those preferred shares and why this MNAV drop is such a crisis for them.
Sure. So preferred shares are essentially a hybrid between a stock and a bond. Investors bought them expecting that massive 11.5% yield.
Which is huge.
Right. But fair value analysis suggests those shares might actually be worth closer to $55.
Wait, really? Why so low?
Because MicroStrategy has the option to step down the coupon rate to the SOFR rate, that's the Secured Overnight Financing rate, which currently sits around 3.6%.
Oh, wow. So if they do that, the yield just crashes.
Exactly. But the bigger issue is their fundamental business model. MicroStrategy's engine relied on constantly issuing new equity at a premium to buy more Bitcoin. If your MNAV is below 1, issuing new equity only dilutes and destroys existing shareholder value.
So the funding engine is just stalled out.
Yep, completely stalled.
Ripple's CEO, Brad Garlinghouse, publicly called this approach a damning indictment of financial engineering, arguing it hurts the broader market. But I have to ask, is this actually a failure of crypto as an asset class? Or is this just a classic Wall Street tale of a company getting overly leveraged on a single trade, and the financial wrappers around the asset are fracturing rather than the asset itself?
It's definitely the latter.
Yeah.
The asset itself is doing exactly what it was programmed to do. It's the speculative wrappers that are bleeding.
Interesting.
And you see the same pain in the retail ETF market. The average investor in BlackRock's spot Bitcoin ETF, IBIT, is down roughly 40%, simply because so many retail inflows arrived right at the market peak.
Right, buying the top.
Exactly.
Yeah.
Meanwhile, Circle's stock dropped over 16% to $62, getting booted from the Russell growth indexes. And that's largely due to competitive threats from a new 140-company stablecoin consortium called OpenUSD.
So the speculative leverage game is failing. But here is where we transition to the new way Wall Street is using this tech, and it's incredibly successful. Away from the retail pain, traditional finance is quietly upgrading global infrastructure.
Yeah, the back-end stuff.
Right. Look at Chainlink. They just launched Project Pangea with a consortium of more than 50 banks across 16 countries.
Which is massive.
Right.
They are targeting the global foreign exchange market, which settles $9.6 trillion a day. Historically, that settlement takes 2 days, known as T+2.
Pause there, because if you're wondering why Wall Street cares so much about shortening that settlement window, think about the mechanics. What actually happens during those 48 hours?
Well, during those 2 days, the money is essentially in limbo. That creates a massive window of counterparty risk. The risk that the other side of the trade defaults before the money actually moves. To protect against that, banks have to lock up billions of dollars in collateral.
That sounds doubly capital inefficient.
It is. It's terribly inefficient.
Yeah.
Project Pangea changes that by using Chainlink's cross-chain infrastructure, Swift's messaging rails, and regulated stablecoins to settle those trades at T+0.
instant, atomic settlement.
Exactly.
And it's not just back-end banking either. On the retail side, Robinhood Chain just went live on mainnet as an Ethereum Layer 2 built on Arbitrum. They are bundling stock tokens and DeFi lending into one platform for retail users in 120 countries.
And notably, they are completely avoiding the U.S. market to dodge the regulatory mess we talked about earlier.
Yeah, they want no part of it.
And I mean, the yields they're offering are pulling massive liquidity. Eligible users are accessing around 7% APY on USDG lending via a protocol called Morpho. Standard Chartered just initiated coverage on Morpho, projecting its token will hit $60 by 2030. Combine that with Kalshi, a regulated prediction market, seeking a $40 billion valuation just 7 weeks after a $22 billion raise, and you see a clear framework forming here.
Utility and infrastructure are thriving while pure speculation is taking a hit.
Exactly.
It's a complete tale of two realities. But, while humans in suits argue about corporate leverage and two-day settlement windows, we might be completely missing crypto's actual killer app.
Oh, for sure.
Because the real native users of this technology in the future, they might not be human at all.
Yeah, and this challenges everything we've assumed about blockchain utility for the past decade. We've spent years trying to force human consumer behavior onto blockchains, struggling with the friction of seed phrases and clunky wallet interfaces.
Right.
But human friction doesn't matter to software.
This is wild. The July newsletters highlighted an incredible announcement from Cloudflare regarding their monetization gateway using the BY402 protocol. Let me just set the stage for you. AI agents are now requesting web content 100 to 10,000 times more often than human visitors.
It's insane volume.
And that completely breaks the traditional internet business model.
Yeah, because the entire web basically runs on an attention economy. Websites provide content for free because human eyeballs look at display ads, which generates revenue.
Right, but AI agents do not look at ads.
No, exactly. They do not sign up for $9 a month subscription plans. They scrape the underlying data and leave. It is purely extractive.
So Cloudflare is solving this by allowing websites to charge AI agents for every single request using stablecoin micropayments. We're talking fractions of a cent settling in under a second.
It's brilliant.
But the really brilliant part is the mechanism itself. The payment is the credential. Explain how that actually works under the hood.
Okay, so in the traditional web, to access an API, an engineer has to register an account, enter a credit card, get an API key, and then embed that key in their code.
It's a whole process.
Very manual. With the BY402 protocol, an autonomous AI agent simply hits a web endpoint. The server replies with an invoice. The agent automatically pays that micro-invoice cryptographically, and the server instantly unlocks the data. No signups, no human intervention. You pay the toll, you get the data. Cloudflare already hit 500,000 daily transactions doing this in June.
And this goes way beyond just software agents scraping text. Let's talk about robotics.
Yes.
The private robotics market is valued at $263 billion, yet it's virtually ignored in crypto narratives.
Well, think about the fundamental banking constraints of a physical robot. An autonomous delivery drone cannot walk into a Chase branch, present a driver's license, and open a checking account.
Obviously not.
Right. They cannot hold a legal identity, and they certainly cannot route money through the traditional ACH banking system, which relies entirely on human KYC, know your customer laws.
This was my absolute aha moment going through our sources.
Yeah,
because crypto was originally designed by cypherpunks to bypass human governments, but the architecture they built accidentally created the perfect banking infrastructure for R2-D2.
That's exactly it.
Crypto provides permissionless machine identity and programmable machine-to-machine payments. So if an AI drone needs to pay a charging station, it just uses a stablecoin.
And we're seeing an entire stack emerge just for this. Fabric for machine payments, IoTex for physical telemetry, virtuals for agent coordination. It completely shifts our understanding of crypto from being a highly volatile asset traded by humans on Robinhood into a vital, invisible utility for autonomous machine coordination.
Which is incredible to think about until you bring it back down to earth. Because if we're going to entrust $9 trillion FX markets and an entire autonomous robot economy to these blockchain rails, the underlying infrastructure has to be absolutely flawless.
That has to be bulletproof.
And right now, these newsletters show some truly alarming vulnerabilities. We have to look at the mechanical failures happening today.
Yeah, we really must separate the theoretical promise from the current production reality. Take Base, for example, one of those prominent Layer 2 networks. On June 25th, They suffered a nearly 2-hour outage, followed by another 20-minute stall the next day.
This locked decentralized finance users out entirely. No trades, no liquidations, no withdrawals, and the cause was a consensus bug tied to their single sequencer design.
Right.
Walk us through why a single sequencer design creates such a massive choke point.
Well, a Layer 2 network like Base processes transactions off the main Ethereum chain to keep costs low, and then batches them together to settle them later.
Okay.
The sequencer is the entity responsible for ordering those transactions. Base uses the single sequencer. When that specific node encountered a bug, there was no decentralized backup validator set to take over.
Oh, so the whole chain just halted.
Just froze. It requires manual restarts by node operators. A single sequencer Layer 2 carries the exact same operational risk profile as a centralized server at a Web 2 company.
And it's not just the Layer 2s either. The base layer, Ethereum itself, is dealing with a severe structural issue called slot zero block reorgs. Basically, blocks are being orphaned at the transition point between epochs.
Yeah, this is a big concern.
The data shows slot blocks are being orphaned at a rate of 1.17%, compared to just 0.16% for other slots. Let's break this down. What does it actually mean for a block to be orphaned?
An orphan block is basically a block of transactions that was valid and solved by a miner or validator, but ultimately rejected by the broader network because another block was propagated just slightly faster.
So it's essentially wasted effort.
Exactly.
I was reading through the research, and the best way to visualize this is like a relay race. The transition point between epochs is the moment the network has to pass the baton. And right now, it's like passing that baton exactly as a massive gust of wind hits the track. It's the moment of peak network load, and the builders are just dropping it.
That's a great analogy, and the sources point out this is being driven by the behavior of local block builders, specifically the exchange Upbit, who counts for roughly 18% of all those slot orphans.
Wow.
Yeah, it's a production engineering issue. What's happening is a relay bid miss.
A relay bid miss.
Yeah. When network latency causes a validator to miss the highest bid from an external builder, they default to constructing the block locally. But doing this at the exact moment of an epoch transition takes too long, causing the rest of the network to move on without them. Hence, the block is orphaned.
So researchers are proposing a fix to extend the attestation deadline from 2 seconds to 3 seconds, just giving them a little more breathing room to pass the baton.
Right.
But the sources also mention they are looking at advanced mechanisms like DAG-based Shapley values to prevent nodes from forming static coalitions. Okay, you are going to have to explain what a Shapley value is in this context.
Yeah, that sounds super dense. A Shapley value comes from cooperative game theory. It's a mathematical way to fairly distribute the payout among players who work together to achieve a goal based on their individual contribution.
Okay, I follow.
So applied to Ethereum block building, using a directed acyclic graph, or DAG, with Shapley values, ensures that no single large entity or static coalition can dominate the block building process and extract all the value.
So it forces a fairer, more dynamic network, preventing the centralization that leads to these vulnerabilities.
Exactly.
So we have researchers mathematically tweaking deadlines by a single second and applying game theory to keep the chain from fracturing. Meanwhile, there is a literal existential threat hurtling toward us. Let's talk about the quantum boss fight.
Oh, boy.
On June 22nd, President Trump signed 2 executive orders accelerating quantum computing in the U.S. The Department of Energy is tasked with building a fault-tolerant quantum computer, and federal agencies have strict deadlines to migrate to post-quantum cryptography by 2030 and 2031.
This is often referred to in cryptographic circles as Q-Day.
Q-Day.
Yeah, and the specific threat to Bitcoin and other blockchains is an algorithm called Shor's algorithm.
Break down the mechanics of Shor's algorithm for us. Why is it so dangerous to crypto?
Modern cryptography, specifically the ECDSA and Schnorr signatures that secure Bitcoin, relies on the fact that classical computers cannot easily factor massive prime numbers or solve discrete logarithms.
It would take a normal computer thousands of years, right?
Exactly, thousands of years to guess your private key from your public key. But Shor's algorithm, running on a sufficiently powerful quantum computer, solves that math problem exponentially faster. It can derive a private key from a public key in a matter of hours.
And the exposure numbers are terrifying. Project 11 estimates that roughly 7 million Bitcoin are sitting in addresses with exposed public keys. That includes 1.7 million coins in dormant wallets, and crucially, the estimated 1 million Bitcoin mined by Satoshi Nakamoto himself.
The holy grail of crypto wallets.
Literally. But I have to ask, if the whole network uses the same cryptography, why are only those specific 7 million coins exposed? Why not all 21 million?
It comes down to how early Bitcoin transactions were formatted compared to today. In the very early days, including when Satoshi was mining, Bitcoin used a format called pay-to-public key. This meant the public key was entirely visible on the public ledger. And if a quantum computer can see the public key, Shor's algorithm can crack the private key. Later on, the network transitioned to pay-to-public key hash. In this format, the public key is hidden behind a cryptographic hash until the exact moment you spend the coins.
And a quantum computer cannot reverse a hash function.
Correct. So as long as you haven't reused an address, your unspent coins are currently safe.
That is wild. The very design of early cryptography is what makes Satoshi's legendary vault a sitting duck. And the problem is, while a federal agency can simply mandate an IT upgrade by 2030, a decentralized network like Bitcoin cannot just hit an update button.
Exactly the issue. The community is deeply divided on how to handle this. There are proposals like BIP 360 to create new quantum-resistant addresses. Then there's BIP 361, which goes much further.
What does that one do?
It suggests setting a hard migration deadline and then forcibly freezing non-compliant UTXOs, meaning the network would lock up any unspent transaction outputs that haven't migrated.
Oh, wow. Freezing people's funds goes against the very ethos of Bitcoin. No wonder it's contentious.
Yeah, it's a massive debate.
And there is no confirmed activation timeline for these upgrades. So we're sitting here hyper-fixated on a 2-hour single sequencer outage on Base today, debating whether a retail ETF investor is down 40%, while a literal quantum machine is being built that could crack open Satoshi's 1 million Bitcoin vault by 2030.
It perfectly encapsulates the adolescence of the industry you mentioned at the start. If we synthesize all the sources we've explored today, we are watching crypto mature in contradictory directions.
For sure.
On one side, it is becoming a highly regulated Wall Street integrated tool, settling trillions in FX trades and dealing with corporate leverage crises. On the other side, it is quietly establishing itself as the essential financial plumbing for AI agents and robotics.
Yeah.
Yet, underneath it all, the foundation is still wrestling with centralized sequencer bugs and a ticking quantum time bomb.
It is so much to wrap your head around. The scale of the transition is just staggering. But as we close out this deep dive, I want to leave you with one final thought to mull over. We talked about how by 2030, AI agents and autonomous robots might be the primary volume drivers and transactional users of these blockchain networks.
Which leads to a fascinating, totally unaddressed question. If the machines become the primary economic citizens of these networks, will those non-human actors eventually be the ones coordinating, lobbying, and perhaps even voting on the cryptographic upgrades needed to defend their own capital against the quantum threat?
Wow. An autonomous AI agent voting on a Bitcoin improvement proposal to stop a government quantum supercomputer. That is a reality we might actually see. Thank you so much for joining us on this deep dive. Keep questioning the information around you, keep looking past the headlines, and we will catch you next time.
Spoken Tech, for your ears.